Here we are in chapter 5 where we're going to be talking about some measurement concepts. You might be overwhelmed by some of the phrasing and terminology that we're going to be using, but I assure you that the concepts are relatively straightforward as long as we can keep them straight. So let's not get too worried about what the words look like. Let's focus on the concepts and kind of get a very aerial view of how reliability works. In chapter 4, we talked about validity and some measures of validity, and we'll talk a little bit about validity here too. But here we're focusing on reliability and whether or not some kind of measurement is stable. So some of the objectives that we're going to look at is how to define reliability, and really it's about stability. And we're going to look at three major ideas here. One of them is called test-retest reliability. One is called internal consistency, and the last is inter-rater reliability. So those are the three very basic ways that we can look at reliability. We are going to talk about construct validity, which we've talked about before in chapter 4, and how we establish construct validity. And there are several ways that we can do that. Among them, we can use face validity, content validity, predictive validity, concurrent validity, convergent validity, and discriminant validity. And once we look through some examples, you'll be able to separate those out, and they won't be so nebulous to you. We're also going to talk about reactivity. And that's how we react to being measured. And you'd be surprised at how often that's a factor in doing social science research. And then last is a review of the levels of measurement. We're not going to do a lot with that because we cover that in stats. So I'm going to probably just gloss over that or just refer you to the book for a refresher course on those concepts. So let's jump right into it. And we're going to talk about just the basic idea of reliability and a couple of things that go into reliability so we can lay some groundwork. Reliability is consistency or stability of a measure. Now, when you think of reliability, you can think of a bathroom scale, what you step on to weigh yourself. A reliable bathroom scale will give you the same result each time you step on it if you stepped on it within, maybe 30 minutes of the last one that you did. Obviously, if you step on a scale 5 years and it's not reading the same, you're not going to think that your scale is unreliable. You're going to think that you changed somehow. But if you stepped on the scale maybe 10 times in 30 minutes, you should get the same measurement unless you've eaten a lot or something. So the reliability of the measure is whether or not our measurement is stable. And there are different ways that we can measure stability that we'll get into in just a little bit. So the true score is the real score on the variable. So whatever the actual real score is, that's called the true score. By the way, we don't always know what the true score is. We just rely on the measurement to give us some kind of output. For example, if we stepped on our bathroom scale and it said 150 pounds and we weighed 150 pounds, then we would weigh the true score. But let's say that we stepped on the bathroom scale and it was calibrated incorrectly, and it said that we weighed 180 pounds when we actually only weighed 150 pounds. All of a sudden, we don't have a measurement that's valid. There's something wrong with it. However, if we stepped on that bathroom scale and it said 180 pounds 5 times in a row, it would still be reliable even though it wouldn't be reflecting the true score. So there's an interesting thing there. We can have a reliable measurement, but it doesn't mean it's valid. There can be some error there, and we call that measurement error. The difference between the true score and the measured score is what we call measurement error. And when we use a concrete example like a bathroom scale, there are ways to determine if our bathroom scale is accurate using some established weight consistencies. So if we had a 25-pound metal plate that was from the gym, and we put that on our scale, and the scale reported that the weight of that plate was 25 pounds, then we would have a good valid measurement, and it would be measuring the true score. But if we put the 25-pound plate on the scale and it said that the 25-pound plate weighed 30 pounds, we would have a measurement error of about 5 pounds. So when we're talking about reliability, we're talking about the repetitive ability for us to get consistent or stable results when we expect them to be consistent and stable. If we don't have a reliable measure, then we could get some inconsistent results. The true score, again, is whether or not we are getting a valid score. And the measurement error is the difference between the true score and the score that is being reported. If we use a non-concrete example, like if we wanted to measure IQ, we could measure IQ and we could measure somebody's IQ and they could have an IQ of 100 according to the IQ test, but they could actually have gotten lucky and guessed correct on some answers, and their IQ might only be 90. There could be some measurement error there. The issue is that we don't always know when there is measurement error because we don't know that there is a difference between what somebody's score actually is, like a 90 on an IQ test, and what they actually scored on the test based on luck, which is 100. So there are some rather interesting ways that we can look at the measurement error and whether or not we can accurately reflect it based on the given situation. When we talk about reliability of measures, we focus a lot on what's called the Pearson product moment correlation coefficient. That's just correlation, friends. Don't get too bogged down by the name of it. When you get smart and you can name your own statistical procedure, you can call it whatever your name is, product moment correlation coefficient. It's fine. I don't have one yet, so I haven't reached that kind of level of smartitude, I suppose. So we use the correlation coefficient to tell us how strongly two variables are related to each other. So if we want to know if two measures are reliable, we can look at the way that they're measured across maybe different trials and see if those measurements correlate somehow. As a review, we know that the correlation coefficient ranges from -1 to +1. The closer to positive or -1, the stronger the correlation. We talked about that back in chapter 4. So when you think of reliability versus unreliability, we can look at the scores on a test. So let's say that we have a group of people that took a test many times. So let's say that it's a measurement of intelligence over time. And let's say that we had 10 people take an intelligence test 5 times in a year. And on average, they scored 100, which is usually how it goes. But in one group, the type of test changed from administration to administration. So in one group, you see a lot of spread in these scores. So even though they should get the same scores from time to time, they're not. So that means that measurement is unreliable. There is a wide spread of scores in here. But if the individuals take the test that's about the same every time, maybe not the exact same questions, but the same format, then you're going to get a measurement that's relatively reliable because the scores don't change that much from administration to administration. So just graphically, we can look at the reliability in terms of how spread out a measurement is. Now, we know that generally the normal curve is prevalent in nature, but if we're looking at reliability, we don't want the scores to change very much between tests. Imagine if you got on a scale and you weighed 100 pounds, but in some cases the scale had you weighing 85 and sometimes it had it weighing 115. That would be a very unreliable measure. But if you got on it and you weighed somewhere between 98 and 102 pounds every time, that's reasonably reliable. I mean, hopefully our scale would be exactly right every time, but when we're talking about the comparison between reliable and unreliable, it's a fair example. Let's jump into some reliability of measures, and we're going to start with a very basic one called test-retest reliability. In test-retest reliability, we assume that if we give somebody the same type of test 2 times in a row, they should get about the same responses. So let's say it's a spelling test in a 5th grade classroom, and we had 25 students that took the spelling test, and then we had the same 25 students take a spelling test the next week with words that were of the same difficulty but not exactly the same. We would assume that those scores would be correlated, that if somebody scored high on the first test, they'd probably score high on the second test. But if somebody scored low on the first test, they'd probably score low on the second test. We expect there to be a high correlation between those two tests, and if they are, then we have good test-retest reliability, meaning that the test from time to time stays stable. Now, if there were some kind of issue where there were significant differences between scores between the two spelling tests, we would have an unreliable measure. And there could be lots of examples of why that could be. Maybe one of the spelling tests was taken in the afternoon when the children were more awake, and the other one was in the morning when they were kind of sleepy and not able to focus so much. Or maybe there was a verbal test versus a written test. So, you had somebody that would say the words and then you would have to spell them. Or maybe there was one instance where they flashed the words for 1 second so that the kids could see what the word was so that they could spell it correctly. Now, obviously, they could probably copy it, but a second's not that long. So we could look at different ways of measuring measuring spelling aptitude different ways, but as long as they are reliable, they will have the same kind of scores from administration to administration. Alternate forms reliability goes along with test-retest reliability. Alternate forms reliability is when the same group takes the same test twice, but the test is a little bit different. So the first example was kind of like an alternate forms reliability where there are two different types of a spelling test. The deal with alternate forms reliability is that we can avoid the learning effect. We can avoid an effect that says that people will remember how they responded. They'll remember the test from administration to administration. Think of taking a driver's test, a written driving test. If you scored, maybe a 70% on the written driving test, and then 6 months later you had to retake it and you scored a 90%, people might say, wow, you did a really good job of studying and everything. Well, really what could have happened was that you could have learned what's on the test and then retaken it and done better because you knew what was going to be on the test, not because you necessarily studied harder or anything like that. So what would be more reliable measure of your ability to learn what's on the test or learn the driving skills is an alternate forms reliability situation where we had a test that had all different questions but were still related to driving. And then that would test whether or not you studied harder or if you just learned what was on it. So we need to be careful that we don't accidentally credit somebody's progress on a test to their increase in learning rather than the fact that the test was the same or close enough to the same from administration to administration. And that's the basic idea of test-retest reliability, is giving the same test twice and seeing if the scores correlate. Now, when we are looking at reliability, we also need to consider this idea of what's called internal consistency reliability. What that means is there some stability within the measure itself? So if we go back to that idea of a spelling test, and let's say that there were 10 words on the spelling test, and everybody in the classroom got 9 words right, but only half of people got that 10th word. Maybe it was a little bit more difficult than the rest. What would happen is that spelling test would suffer from internal consistency issues, meaning that all of the questions are pretty much the same. Everybody got the same kind of responses, but that 10th question was a little bit different. So it doesn't fit the rest. That means that we have internal consistency issues. So that's the issue where we assess reliability and use responses only one point in time for the same group over several trials. So there are several ways to find out if we have a consistent test. Now, this could be a test of anxiety to see if you have some kind of anxiety disorder. It could be how much you like Olivet College based on a few factors, the social life, the academic life, the food, where we are in the state, kind of regionality. We could look at that and we could see if something was a measure of the actual liking Olivet College or not. So split half reliability is one way we can do that. What we can do with split half reliability, and we'll look at an example in a moment, is we can take half of the scores from a particular study that we're doing. We can take half of those scores and compare them to the other half to see if there is some consistency between them. And what's interesting about the split half reliability is that we don't actually have to split them up in a very meaningful way. All we really need to do is take half of the questions and compare them to the other half to see if the responses were similar enough. And there are a couple ways to do that, but we're just going to focus on the concept rather than the actual method of that. As a matter of fact, validity and reliability measures are fairly sophisticated measurements that we would have to take. We're going to look at some numbers, but just in a pretty standard way. We're not going to have to do any mathematical calculations. So again, if we have a high correlation between the two halves of a particular test, then the questions are measuring the same things, which is good. We want all the questions to measure the same thing. If we have low correlation, that means that somewhere in there is inconsistency, meaning that some of the questions are not measuring the same things. Another way that we can look at internal consistency is through what we call item total correlations. That means we can take each possible combination of a score or of questions and compare them with the other combination to see if there is a correlation. And ideally, there would be a correlation with all of the scores. A low correlation means that some question might be measuring something else that can be discarded. Something that you might hear about or see in your research articles is this idea of called Cronbach's alpha. And Cronbach's alpha is when you can see the definition there. It's the average of all possible split half reliability coefficients. That's kind of a boring way to look at it. What Cronbach's alpha does is it assigns a number to a question. And the number essentially rates from a score of 0 to 1 how well that question fits in with all the other ones. And it's based on correlation. It says, how well does this question correlate with the others? If it has a low correlation, that means that the question does not fit with the other ones. It can probably be discarded. So let's take a look at Cronbach's alpha real quick. Just an example of what that might look like. A Cronbach's alpha looks at the item total correlation. So what that means is that we take question 1 and we see if question 1 correlates well to question 1. And of course it does, because it's the same question. It's always going to correlate, right? So it's a silly thing, but there it is. Then we look at question 1 compared to question 2. That has a correlation of 0.34, probably pretty strong. Generally, anything over 0.3 is a strong enough correlation when we're looking at this. That's just kind of a behind-the-scenes thing for Cronbach's alpha. Then we look at question 1 compared to question 3, and we have a correlation of 0.54. Question 1 to question 4, 0.18. This is actually kind of low. We'll come back to that. Then we look at the other possible correlations. So the correlation between question 3 and question 2 is 0.32. Question 3, question 4 is 0.47. Then the last correlation is between question 3 and question 4, which is 0.41. So you can imagine if you had many questions, like 100 questions, you'd have a 100 by 100 matrix. This is called a matrix, by the way. Isn't that fancy? You'd have a 100. You'd have what, 10,000 boxes, and that's a lot of boxes. But anyways, we look at the correlation between question 1 and question 4, and that has a correlation coefficient of 0.18. Question 1 and question 4 do not correlate well, meaning that either question 1 or question 4 is not measuring the same construct as the others. It would take a little bit more analysis to figure out which one was going on here, and we can actually do that in SPSS using a Cronbach's alpha reliability test, and it would tell us what the strength of question 1 was or the strength of question 4 was to see which one was lower, and we could get rid of it. But just for the sake of demonstrating what we're looking at here, we can see that question 1 and question 4 do not correlate well, and we'd have to look to see which one of those we would get rid of. So that's kind of a small introduction, a very small introduction to Cronbach's alpha, and one of the ways that it can be observed. Now, it's a lot more sophisticated to calculate it than what's here, but this is just a good demonstration of how we can look at these questions to see if they correlate well together. Now, the second way that we can look at correlation, or excuse me, internal consistency, is by using what we call that split half reliability. So split half reliability is a correlation of the total score of one half of the test compared with the total score of the other half of the test. And here's what I've done here. Let's say that we are measuring happiness. And we're looking at 3 people have happiness scores across 8 days. So the average happiness score for day 1 is 5.33. The average happiness score for these 3 people on day 2 is 6, and so on. So on day 1, you have 5.33, 6, 4.67, 4.33, 6.33, 5.675, and 5.67. And let's say that we wanted to see if just asking somebody on a scale of 1 to 10, how happy are you, was a reliable measure. And we can do that by looking at the average the average for each day, and then splitting those in half and seeing if they correlate to one another to see if that is a reliable measure. Now, by the way, people can feel better and worse on particular days. Maybe people feel better on Fridays and worse on Mondays, and that's okay, because if we split these up in any random way, then we will be able to systematically control for that, just like we talked about in Chapter 4. So we know that there might be some variation here, and that's okay. We can see variation. But we want to know if generally there's a correlation between the two halves of those groups. So what I've done is I've just taken all of the odd numbered days and called that the first half, and all the even numbered days and called it the second half. So the first day, 5.33, goes into the first half. The second day, where they had an average of 6, goes into the second half. 4.66 goes into the first half, 4.33 goes the second half, and so on. And we look at this to see if there is a correlation between these scores in terms of how happy people are. And I took this and I created, and I brought forward the first and second halves, and I created just a scatter plot. And by the way, we'd want to have many, many more scores in each column to do this. But as you can see, there tends to be an upward trend of happiness scores across the days. And generally, people tend to be happier across the days. So if you have each half, you are indicating that there is a high correlation between those two. Now, this is just a graphical representation, but the split half reliability is a good indicator using the graphical representation. So in this case, you can see that there is an upward trend here, meaning that these scores do correlate to one another. So we could probably just say that this has good split half reliability, so that asking somebody how they're doing on a scale of 1 to 10 in terms of their happiness appears to be a reliable measure. Now, the last kind of reliability that we're going to talk about is what we call inter-rater reliability. Inter-rater reliability is the ability for two people to agree, or two or more people, to agree on a measurement. Usually this comes from observations based on different raters. We use inter-rater reliability an awful lot in qualitative research, where we are coding some kind of information. So if you're looking at somebody talking for 5 minutes and you are measuring negative self-talk, so the number of times people talk down about themselves, and you have 2 raters, each person is watching and they're going to put a check mark each time somebody says something that is negative self-talk. Ideally, you would have the exact same scores for each rater. So each rater would witness 8 times that somebody had negative self-talk. But if there is a big difference between each rater, so let's say that the first rater said that they saw 8 instances of self-talk, and the second rater said that they observed 2 instances of negative self-talk, they would probably have low inter-rater reliability because those two would be negatively correlated. Now, or not correlated at all for that matter. So inter-rater reliability is really just a matter of agreement. Do 2 or more people agree on what they witnessed? Now, some broad ideas about reliability and accuracy, I've kind of alluded to it already. Reliability indices, so whether it's Cronbach's alpha or Cohen's kappa or whatever it is, we know that just because we have reliability, it doesn't mean that we have an accurate or a valid measurement. Okay, a measure can be reliable, but not necessarily accurate, kind of like that bathroom scale example. You could get the same wrong answer over and over again. So it could be reliable, but not accurate. The book summarizes the 3 types of reliability that we've been talking about. So if you would like to use this as your review, you certainly can. But I encourage you to get a better understanding of it than just this summary, so please don't rely on just this. Do use the text, ask me questions, and take a look and review the slides prior to this. When we talk about reliability, we also have to talk about the idea of construct validity, because if we're talking about the idea of stability of measure, we still need to talk about the fact that we need to have some kind of accuracy of measurement. It doesn't mean anything for us to have reliable measures if what we're measuring isn't valid. So construct validity means that we are measuring what we intend to measure. So we look at the operational definition of whatever we're trying to measure it, and we make an attempt to maintain that operational definition using the following types of validity. We're going to talk about these types of validity in class through some activities, so we're not going to get into too much detail here, but you do need to be familiar with them and be able to differentiate them when you see them. So face validity is a very simple type of validity that means that what we're measuring appears to be the construct that we're measuring. It's kind of the first line of defense against not measuring something appropriately. So if we want to measure something like height and we use a ruler, okay, that appears to be a valid way to do it. Just face validity, that's good. That seems reasonable. If we're measuring intelligence and we use an IQ test, that appears to be a valid way to measure IQ. We know that there are other issues that go into IQ tests, but it appears to be something that would measure intelligence. Content validity is when we link the content of the actual test to the universe that defines the construct. So what that means is this. Let's say that we are trying to measure poverty, and we want to know if somebody comes from a poverty-stricken area. We would ask questions that are related to poverty. Simply, how much money do you make? Do you have access to clean clothes? Do you have access to healthy food? Are you able to get transportation back and forth to school or work? And we'll ask several types of questions about poverty, and we will identify those questions to determine if they come from the same universe of content that defines poverty. If we ask something like, what is your favorite TV show? That's probably not a measurement of poverty, so it wouldn't have good content validity. Somebody out there probably has done a study on what people prefer to like based on their poverty status, but that is still not something that is directly related to the construct of poverty. It's measuring something else probably. In predictive validity, we are measuring a criterion, or the outcome, and we're using predictors to determine what that outcome might be. So let's say that we want to know if scores on the SAT can predict success in college in terms of GPA. We would take a look at many scores on the SAT and correlate those scores to the GPAs of the students after their freshman year. And we could then determine if we can predict what somebody's GPA may be within a certain range based on what their SAT scores are. That's a very common thing that people like to see, and we can use lots of different predictors. Instead of just SAT, we could also use high school GPA or the number of AP classes they were in or whatever. But what we're looking for is to determine if there is some kind of validity of measurements when we're trying to predict something else. This is something that social scientists love to try and do, and there are lots of different ways to do it. So predictive validity is simply just that ability for us to make a prediction based on what's going on now, but in a future time. Moving along, we have an idea called concurrent validity. Concurrent validity is an ability for two groups of people to take the same test to see if there are differences between those two groups. So the idea here is that if we had freshmen and seniors taking the graduate record exam, the GRE, we could determine if there is concurrent validity by determining if the differences between the two groups is significant. So the idea here is that the same people are taking the same test at the same time, not that they get the same results. As a matter of fact, you might want them to get different results to see if there are differences between those two groups. So concurrent validity is a way for us to determine if the measurement can be used to sort out groups. Convergent validity, which kind of sounds like what concurrent validity is convergent validity is a little bit different. We want to know if there are two different tests that measure the same construct. So what that means is, could we use two different tests to measure the same thing? So we take the ACT, which is what the SAT is probably most related to, and we could determine if the measurements are the same. And if they are, then we could say that those two instruments measure the same kind of general knowledge about high school academics. So if those two measurements were correlated, so if you got, like a 32 on the ACT and a 1000 on the SAT, that would indicate that you have a convergent validity, or that your measures have convergent validity, meaning that they probably measure the same kind of thing. There are lots of different reasons why we use convergent validity. Sometimes it's to see if we need to continue to use two separate forms of a measurement device, or if we can eliminate one because they do about the same job of measuring the same construct. And then there is discriminant validity. And discriminant validity is kind of a cornerstone of a statistical process called factor analysis. It's a kind of a fancy word, but really what it is if we had 100 questions, and within those 100 questions, we wanted to basically find out two different things. First, we wanted to find out if people are more likely to go to college or go to some kind of job after high school. We could ask 50 questions about each, and ideally those two sets of questions, the 50 questions about going to college and the 50 questions about going to work after high school, would somehow be different. Whether they had characteristically different true or false questions, so you had more true questions about going to work and more false questions about going to college, or whatever it is, the discriminant validity would be indicated by the fact that the answers for all of the questions about going to college are different than the questions about going to work right after high school. So we can discriminate the two factors, going to work after high school or going to college after high school, based on the responses that we get from the respondents. Now, it's more complicated than what it sounds like, because it's a highly sophisticated way of determining if there are multiple factors in a particular line of questions. But the essential idea is that we can determine if questions are clustered together around a certain topic or not. The book offers some examples of the types of validity that we just covered. I encourage you to take a look at that. We'll talk more about this in class because it's a very interesting and important aspect of research methods to be able to talk about convergent validity, discriminant validity, phase validity, construct validity, predictive validity, and concurrent validity. The last thing that we're going to focus on is what we call reactivity of measures. Reactivity is when people respond in a particular way because they are being careful about their responses. They want to look good, so there's a social bias about how we respond, so we want to look favorable with our responses. Maybe we respond a certain way because we don't think that our results will be kept confidential. Maybe we want to make the researcher's hypothesis correct, so we can do what's called hypothesis guessing and just try to help the person out. Or if we know the hypothesis and we want to screw it up, we could respond a particular way. Or if we want to have better responses, we could mess it up that way. Another way that we can mess up a study, I call it messing up. Another way we can react to a study is by using what's called the Rosenthal effect, or an expectancy effect, which kind of is a cluster of different types of effects. But generally, it's responding in a way that you feel like you're expected to respond. And there are lots of, I named several ways: hypothesis guessing, the social desirability bias, etc. But what happens in any of those cases is that our reactivity, the way that we respond, changes based on what we perceive about the study. It all leads to an unreliable measure and an invalid measure. So instead of us being measured on whatever construct or operational definition the researcher is interested in, we're accidentally being measured on something else, and it has to do with how we have changed our response based on our reactivity. So when you think of reactivity, think of how the responses change based on any number of situations, including the social desirability effect, the expectancy effect, the hypothesis guessing effect, whatever they are. Just be aware that reactivity can cause issues, and we do what we can to reduce reactivity. The last couple of slides are about the different levels of measurement. We're going to skip over those because we covered those in stats class. So we talk about nominal, ordinal, interval ratio, which we classify together as scale. And then we also would talk about variables and measurement scales. So we know that there are some some levels of measurement that are used for different types of measurement scales. And we'll talk about that in stats class, so we're not going to really focus on that here. So that's Chapter 5, the measurement concepts. Again, I encourage you to go back through the book and take a look and see if there's something that you're a little bit fuzzy on to get clarification there. Always feel free to ask questions. We're going to use this information to do some work with an article response, and it's generally good information to have as you're going forward on your projects, and especially with your article responses. So I look forward to seeing what you can do with it.